New fungal infection has been discovered in China. Scientists uncovered a species of fungi that had never before been seen in humans. They say warmer temperatures could drive its evolution for the worse. Scientists in China discovered a previously unknown fungal pathogen that can infect humans. The fungus called Rhodosporidiobolus flavialis was found in clinical samples from two unconnected hospital patients. In experiments, the researchers found that the yeast was resistant to several first-line antifungal drugs at higher temperatures around that of the human body. This temperature also gave rise to hypervirulent mutants capable of causing more severe disease in lab mice, they said. The findings support the idea that global warming can promote the evolution of new fungal pathogens. The researchers behind the discovery wrote in a report published June 19th in the journal Nature Microbiology. The scientists made this discovery after examining fungal samples from patients in 96 hospitals across China between 2009 and 2019. In all, 27,100 strains of fungus were collected and analyzed, and of these, only R. fluvialis, this is what we're talking about here, had never been seen in humans before. R. flavialis was uncovered in the blood of two unconnected patients who, in addition to being infected with the yeast, had serious underlying health conditions. One patient was a 61-year-old who died in an intensive care unit ICU in Ninjiang in 2013, and the other was an 85-year-old who died in 2016 after being treated in the ICU in Tianjin. The report does not note whether the fungal infection directly contributed to these patients' deaths or if they just happened to be infected at the time. As part of their treatments, the patients were given common antifungal drugs, including fluconazole and caspofungin. Lab studies by the team later found that R. fluvialis is resistant to both of these drugs. This is a remarkable and truly unexpected finding which bodes badly for the future, said David Denning, professor of infectious diseases at the University of Manchester in the UK, not involved in the research. Invasive fungal infections, which attack tissues deep in the body, mostly affecting people whose immune systems are weakened due to, for example, HIV infection or as a result of taking immunosuppressant drugs. For example, notably, the 61-year-old infected with R. fluvialis had been immunosuppressed, and the 85-year-old had diabetes, which can hinder immune function. However, rising global temperatures have driven fungi to adapt and extend their geographical locations, their ranges, making some more likely to come into contact with humans. Thus, new pathogens have emerged, including the drug-resistant Candida auris, which has been identified in more than 40 countries since its discovery in 2009. Meanwhile, the development of new antifungal drugs has largely stalled, leaving few options to fight resistant infections. In the new study, researchers sickened immunocompromised mice with R. fluvialis and found that some of the fungal cells rapidly evolved to grow more aggressively. The team then looked at the fungus in lab dishes kept around human body temperature, that's 98.6 degrees or 37 degrees Celsius. At that temperature, the yeast mutated 21 times faster than it did at room temperature, which is around 25 degrees Celsius or 77 Fahrenheit. The heat also made R. fluvialis more likely to become drug resistant. When exposed to the antifungal drug amphotericin B, the yeast developed resistance more quickly at body temperature than it did at room temperature. If yeasts like R. fluvialis are more likely to become virulent and drug resistant at high temperatures, global warming could potentially drive the evolution of new dangerous fungal pathogens, the team wrote in their paper. But as for R. fluvialis, specifically, some scientists argue against jumping to worrisome conclusions. Matthew Fisher, professor of fungal disease epidemiology in Imperial College London, not involved in the research, told Science that yeast should not be seen as major emerging threat. My kind of first feeling here is that there are unsurveyed environments in China where these yeasts dwell, and that these two patients have been unlucky enough to be exposed to them, he told Science. In short, there is not evidence of R. fluvialis spreading widely through the populace despite its concerned features. And this is on Live Science by Emily Cook. Please leave your comments. Thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.